This short video describes a little bit of the background on our Topoisomerase I Assay Kit. And this is a kit that's based on plasmid relaxation that can be used to quantify topoisomerase I activity from any crude source or extract. It's highly specific for the human type 1 topoisomerase. We provide a detailed user manual with this kit, and the order information is provided on this page, as well as detailed instructions which come with each one of the kits. Topo1 has multiple functions and is related to DNA relaxation, and it is essential for all behavior with regard to DNA. That includes DNA replication, transcription, and quite likely DNA repair. Anytime the DNA template is read, it's necessary to adjust DNA linking number through the action of type 1 topoisomerase. So the DNA topology can be manipulated and altered by DNA topoisomerase I, and so this enzyme can adjust intracellular DNA supercoiling. Topo1 has enormous clinical relevance because of its anti-cancer and also, in the case of prokaryotes, antibacterial targeting. Now, this enzyme carries out a very simple reaction with DNA, and that is the breakage and religation of one strand or the other. It's capable of forming a stabilized DNA topo intermediate, also referred to sometimes as a cleavage complex or a covalent complex. Drugs such as camptothecin, and there are a number of derivatives now, can stabilize the DNA topo intermediate, and these drugs are referred to as poisons because they poison the reaction mechanism, and I'll describe that in just a minute. So overall, the reaction involves a transesterification of topoisomerase I on the sugar phosphate backbone. So it's different than a strand hydrolysis and religation reaction. So the reaction intermediate can be disrupted by these drugs that stabilize the intermediate. A representative topo relaxation reaction is shown here. We start with supercoiled DNA shown in this image, and that's also shown here. Engages the topoisomerase I in a non-covalent mode, and this is probably includes a DNA searching function where the enzyme feels along the DNA and tries to find its optimum binding site. This is followed by the cleavage event, and that's shown in this image in the controlled reaction mechanism described some years ago by Jim Shampoo. The covalent intermediate involves actual DNA damage because one strand can be poisoned to a single-strand nick in the presence of this drug CPT or camptothecin. This covalent intermediate then is resolved in a controlled rotation model where the opposing strand, which is intact, passes through the nicked intermediate, and then the covalent intermediate is resolved through a religation step. Technically, it's a transesterification step, as I said. And this non-covalent complex then is formed, and the DNA linking number is now altered in discrete steps of 1. The concept behind this assay is really very simple. Supercoiled DNA, in this case PHOT1, is relaxed in rapid fashion by topoisomerase I to form this molecule, which is has slightly different hydrodynamic properties, allowing it to be resolved from the supercoiled substrate by simple agarose gel electrophoresis. So an example of some data, here you see a gel separation of purified topoisomerase I, and this band on the SDS polyacrylamide gel corresponds to purified topo I, and you can see that the relaxation event, here's your supercoiled DNA converted into relaxed products, is very noticeable, and that the substrate and the relaxed DNA molecules are well resolved in this gel system, lacking ethidium bromide. The further washes downstream that lack the protein are, when we loaded 20 times more volume in this case, simply lack total relaxation activity. So this is a supercoiled DNA, and this little band here, which we amplified in this case, is nicked DNA intermediate. It's a small amount of nicked DNA that's always present in this reaction. However, in this case, we don't see an accumulation of that because there's no topo activity here. This next slide illustrates examples of low topo-1 activity in an extract versus high topo-1 activity. And typically what we do in these kinds of experiments, we do simple twofold dilutions of the extract shown here, and we simply measure the conversion of the supercoiled DNA into its relaxed DNA products. These reactions are very simple and fast. They take 30 minutes to run and probably an hour or two of gel electrophoresis to resolve the products. You can see here that 1 microliter has a barely detectable conversion of the relaxed DNA, and that's quickly lost by 0.25 to 0.125 microliters, just as a relative arbitrary measurement of topo activity based on volume. You can see in this high activity experiment that 1 microliter is strongly relaxing the substrate, and that's simply not diluted out by lower levels. If you continued this dilution profile, eventually the activity would titrate down. Now it's important to understand the difference between linking number and simple nicking, which is sometimes confusing to folks. The linking number is a topological property that defines a linking between one strand and the opposite strand. So it's defined by this simple mathematical relationship here that linking number equals twist plus writhe. Twist and writhe are, without going into a lot of detail, are simple geometric properties that constantly interchange. However, linking number is an integral, it's always an integer, and it can be only altered by breaking and resealing one or the other DNA strands. So topo1 specifically adjusts LK or linking number. To illustrate that point in real data, I show here a relaxation reaction with supercoiled DNA. This is the substrate DNA shown here. And when you incubate with topoisomerase I, you get this ladder of bands. It's very distinguishable, and it's very unique. When you see this ladder, you know that you're dealing with topo-1 activity. So each one of these bands differs in linking number from its neighbor. So here you see a highly supercoiled DNA graphically shown less and less supercoiling. As a molecule is relaxed, its radius of gyration opens up, and the DNA moves progressively less in the gel. And here you see what happens if you introduce a single nick. This would be, for example, from a nuclease. You simply generate this nicked open circular form 2 DNA, graphically illustrated here, that says this is not a topological event, it's simply a nuclease. So it's important to understand that these concepts define the products that are clearly distinguishable from a simple nuclease activity. The kits that TopoGEN provides for assays like this are very strongly supported by our technical staff. We are experts. We have many years' experience in dealing with topoisomerases. Our principal scientists have published over the years and are founders, scientific founders in the field. If you have questions about your data, we're happy to help. You simply can send us the data at support@topogen.com, and we'll be happy to work with you on helping you with your particular experiments. We also provide detailed instructions on preparing crude extracts for the assay, which is very specific for topo1. And we should note that topo1 is not included in the kit, but it is available from our website.